First, I want to introduce our awesome speaker of the night, Edward Archibald. He is the CTO of Continuent. He has an outstanding 25+ years of more like 30? Yeah. Holy cow. All right, that's a topper right there. 30+ years of distributed database systems and technology engineering experience. And he's going to tell us about MySQL high availability. Thank you.
Thanks very much. I'm really happy to be here in New York. I hope to get a chance to come back quite a bit in the near future. It's a great city, so you're lucky to live here. One of the things I was thinking about on the way over here as I was preparing this presentation is that one of the things that we all do, that we all just kind of take for granted, is if you can think of something in our domain, you can go out and you can build something that will do that, whatever you can think of. And so it's it's a very direct path between some set of ideas and actually manifesting it. And even, and today especially, I think one of the things that I've seen change over the many years is just the explosion of open source, the availability of actually really good code to build stuff with. You can build things much more quickly because you have open source available, good quality. And the other thing that's changed significantly is if I want a server, I can just go sit at my desk. I can fire one up on Amazon or in some cloud, within minutes, and that's very liberating in terms of building things and trying out ideas. And so one of the things that I've seen happen a lot that we've all had experience with is you hear about Steve Jobs in the garage. Well, I think that the cloud is our new garage in a sense. And so people are building things very quickly just because they have access to these resources very, very quickly. And everybody in this room is really participating in something that's really a revolution, and it's a data revolution. Because, over time, there's been a lot of growth in terms of the way that data has been used. But now, especially with social networks, social networking, a lot of the mobile devices, people have 3 or 4 different devices, and they're really just data generators. That's the way I look at it. They're just generating data like crazy, chats and exchanges of various types, social networks. So I think we're just starting to see a new explosion in that kind of, what we call big data, but not just big data, but data everywhere, basically. Data generated everywhere, data stored everywhere. So one of the things that we're working on here at Continuent is just ways to basically keep the data safe, keep your applications running, and also allow people to leverage open source technology, which many of us have a large investment in, to actually be able to build applications that are much larger than you typically could if you didn't have some high availability solutions or some scalability solutions. So that's what Continuent's all about, is basically added value to open source by providing things that can help you use it with larger apps. So let me just get started here. Hopefully, this is pretty slide minimal. There's still some slides, but I want to show you quite a few demos. I want to show you some live kind of code in operation because it's really cool and I enjoy playing around with it. So typically, actually, can you turn some of the lights down just a little bit? Or is it really just go off or on?
I have no idea.
Maybe something up in the front here. Might just be a little easier to see. Oops. Okay, so typically the way things start in our domain is somebody has an idea, what if we did this? What if we created a website that did this? What if we created an iPhone app that did this? And so basically, thanks, that's perfect. And so basically somebody will chime in, oh, that's a great idea, let's just go off and build it. And so there you go. Basically you're starting to build something that could have lasting value, or it could just be something that crashes or doesn't really work out too well. But life is really interesting if you actually just use your creativity and do something with it. So, so basically, here you are. You have a credit card, a handful of hosts in EC2, and you work for about 70 days nonstop, and you end up with something that looks like this. Basically, you have a LAMP stack, and you have an application, a web application running on top of it. Maybe you have HA proxy in the picture. A couple of web servers, because you want to have those highly available. But typically what we see at Continuent is we see that people come to us often where they have something like this that's been running for a while, but they still have only a single database right here. It's fine. It's a good way to get started. So typically, let's say somebody gets a good adoption curve, people are starting to use it, so it's starting to build up month over month, and you start to get excited. Oh, this is great, my app is going, people are using it, they're talking to each other, they're exchanging it. Then you see something like this, and maybe you were happy before, but now the hair is standing out on your neck, and you're thinking, oh my God, this is really great, but what happens if our database crashes? Well, what are we going to do to basically scale this thing? How are we going to keep serving it? Did I design my application to be scalable? There's all kinds of questions like this. Actually, it's an interesting point is we actually have a new customer who came to us, and they have an application that currently has about 1.4 million users. I can actually tell you the number of users, but it's something like 1.4, 1.6 million users. And they're actually, what they're expecting is to have 1 billion users in the next couple of years. So the issue is actually, if they actually have 1 billion users, it turns out that their application wasn't really built very well with scalability in mind. And after they got this 1.4 million users, they started to see the cracks in the application, started to see the cracks in the database infrastructure, and their hair was standing on their neck. And they have a couple engineers here in California. They actually sent 2, and now they sent 2 more, and they just need a solution. They just desperately need something. So they're going to have to look at not only the database tier and doing something with that, but they have to look at their application and redesigning it. So it's an interesting problem. If you start to have a successful application, you have 2 things: potential for a real success financially, or whatever you consider to be like success, and you have a real problem to try to make sure it continues to work. So people typically come to us, database server is a single point of failure. And if this thing goes away, you're toast. So typically we find people coming to us for a solution for that particular problem as well as some other problems. Okay, so let's say that you were this application developer, and I'm going to tell you about Tungsten Enterprise. Tungsten Enterprise basically removes the single point of failure by allowing you to cluster a set of database servers in such a way that, we call this a database service or a data service. So we cluster these database servers. We allow applications to connect to them through this component called the connector, which is a proxy for MySQL. And so what this basically does is it basically looks to the application layer like a single database server, but it's multiple database servers joined together for two main purposes. One is high availability, so we can fail over if necessary. And the other thing is basically things like scalability. So those are the 2 main properties that Tungsten Enterprise provides: high availability and scalability. There's some other properties as well, but those are the main ones. So what we're going to talk about today, first is we're going to show you something about Tungsten Enterprise, how it actually works. I'm going to give some demos of that. And then we're going to go through a whole scenario with how did you actually go from that previous picture, a single database server, to a database service with Tungsten in such a way that you actually don't have to interrupt your apps, that your apps can keep running while all of this is happening. We have a lot of experience with this. We have a large customer in San Mateo, in Northern California where I live. They're a SaaS. It's called Marketo. And they're just growing double every year. Their databases, their largest database, basically running on a single set of these hosts is 5 terabytes. And they have, I think, about 16 data sets between 2 and 5 terabytes, and they're growing. So those data, what they do is they actually cluster sets of their customers on a very large set of servers, 3 database servers, with NetApp storage underneath. And basically, this becomes and their solution is basically Tungsten to manage that. So they have very large databases. Well, we've helped them migrate their live pods, is what they call them, from non-Tungsten to Tungsten with basically just a few seconds of downtime, because we have a whole process for doing that. So we're going to show you that process in miniature in a few minutes here.
Excuse me.
Okay.
Question here. May I ask a question?
Yes.
So is the proxy server there just a single server or a group of servers?
Going back to that picture, let me show you here if I can do that.
The proxy there.
Okay, so this is basically it's basically a Java application. It's running in a JVM, And this is meant to show it's kind of running on the web server. We can put them anywhere. These proxies could basically go anywhere. In some cases, what people might do is they actually might have an AJ proxy load balancing across a couple of connectors. You can put the connectors on the database servers. So we don't really care where they are. It's just basically, it's the way that you connect to the cluster. So if you have an application that's connected to MySQL directly, what you do when you migrate to Tungsten is you basically connect to one of these proxies, and the proxy will put you through to the database server. And I'll explain basically why the proxy's in this picture, why it's important and why it's necessary. Okay, so one of the properties of Tungsten Enterprise is automated failover. So some sort of a failure on a database server could be a failure of actually the server crashes. It could be a host failure, that host just disappears. It could be that there's a network outage, so you can't actually get to this host. So what we do is we detect various kinds of failures. In this particular picture, and by the way, by convention, this is a master database server, and these are slaves. I forgot to mention that. But so this is basically just a cluster where this is the master and the slaves. So if there's a failover, what we want to do is we want to take and promote one of those slaves as quickly as possible and make it the master. Now, I did these slides in a kind of a fevered rush over the last couple days. There are quite a few details missing about how this all happens, and I'd be happy to explain that in a lot more detail, perhaps after the talk. For today, what I'd like to do is just go very quickly over the main functionality and show you a demo, and then if we have some time at the end, I'll actually show you a diagram of all the components, how they're interconnected with each other, and then how these things work at a sufficiently greater level of detail, if that's what you'd like to do. So. Okay, so the automated failover kind of went by us there. It was an animation. Let me just go back a little bit. So the basic picture is that it selects one of the slaves. In this case, it selected the one on the left. Makes that one the master, and then basically takes this slave, reconfigures the replication, so now it's replicating from the newly elected master. Now, one of the things that's happening at the application layer is the application is connected to that connector that you saw, and the connector will actually shield the application from some of these failures, and I'll show you actually in a demo. It's more interesting to see it actually happen during the demo. So automated failover is one of those kind of features. And I'm just going to show you a very quick demo of Tungsten Enterprise. And what I'm going to show you is how we have integrated backup and restore into the clustering. I want to switch to master. And so unlike a kind of a unplanned failover where the master fails and we promote one of the slaves, you can actually switch the master intentionally in such a way that applications have no impact or very little impact. So it's a very interesting thing that people use very often. Our customers use basically when they're doing things like schema upgrades or different kinds of application upgrades, or where what you'd like to do is you'd like to restart the MySQL instance that's the master right now and put more memory in the box, or for whatever reason, there are lots of reasons where you want to switch the master, do something to the master, and then put it back in the cluster. We're also going to look at basically how the system is resilient to some things like slave failures. And then I'll show you the automatic failover. So we're going to actually just see a demo of that right now. So let me just ask any questions right now about anything. Maybe, it's pretty high level, I know, at this point, and I will get into details, but is there anything anyone would like to ask before I go on to the demo?
Tungsten is a product of Continuent?
Yes, that's a good point. Tungsten Enterprise is Continuent's clustering solution. We also have a product which is called Tungsten Replicator, which is open source. It's a Google project. And what we do is commercially, you can do lots of projects where you have Tungsten Enterprise commercial product for high availability and scalability. And we integrate that with an open source product to do some very advanced kind of replication topologies that you couldn't otherwise do. And I'll show you actually some of the details of that a little bit later. So let's see, let me get a little demo going here. Let's see if I have connectivity still. I was losing these connections. This is great. I was not losing them now. Wonderful. Cool. Okay, so let's see here. Okay, so I actually have Tungsten Enterprise cluster set up here and running on these hosts. These are just some of our test hosts. I'm going to get this a little organized here. This is just a really simple application I just hacked together recently just to give you kind of an interactive picture of what's going on in the cluster, because our main cluster manager is a text-based command line tool. But for the purposes of the demo, this is going to show you what's going on as I do it. So let me explain what you're seeing here. This basically says at the top left there, it says SJ. That's the data service name. So we use San Jose. SJ stands for San Jose. I also have a data service I'm going to call NYC, New York City. And this is going to be important because I'm going to show you something where these data services are actually geographically separate. And we're going to basically show you how you can put them together to do other kinds of failover, like failover across geographic regions, that kind of stuff. But for now, what we have is we have a data service called SJ. It has two servers, two hosts basically. The one that's the master right now is m1.continuent.com, and the one that's the slave is m2.continuent.com. So what this shows right now is that if you see at the top here, let me see if I can find that here, it's easier. At the top here, what this says is to the right, it says online. What that means is applications can actually connect to the underlying database server through the proxy. If it said offline right there, it means that if an application tried to connect to the, to Tungsten through this proxy, it would just basically hang or get an exception, depending on how you configured it. And that's going to be important when we start to talk about failover, because one of the things that we do with failover is we make that database server completely fenced off and unavailable to the application while the failover is going, and then we will make it available again. So the slave then, as you can see, is online. So the other thing you can see in this drawing is we have these two components are basically running on that same server. The replicator is a Tungsten component, and it basically does what it says. It replicates. It basically is responsible for doing replication. And on the master, what the replicator is doing is it's extracting data from the MySQL bin log. And on the slave basically, the slave replicator connects to that replicator on the master and gets the log. So what we're doing is we're kind of mirroring what happens in MySQL replication, but our own replication has some properties that make it more suitable for things like failover, and also more suitable for things like doing multi-master, bidirectional replication, those kinds of things. So what I'm going to do now is fire up the command line tool, which is called cctrl. You can see I have a couple of data services listed here, and I'll explain more about what that's about a little later in the talk. Now, if I do an ls, this is a command line tool. It has a lot of the features of bash script, bash command line, but it's not a bash script. It's really is an application, a Java application. But I can do command line history like that. I can just up arrow to different commands. Again, what you're seeing here is what's mirrored already on the left-hand side there, and you can see the two data sources with a bit more detail. And up at the top here also, you can see these are all proxies that are running on different hosts. So actually in this network, I have 4 different connectors or proxies running. So one of the things I'm going to do is I'm going to just do a backup of this slave for now, because a little bit later in the demo, I'm going to do some failover, and I may need to restore from a backup. Now with Tungsten, one of the things you can do is you can integrate whatever backup kind of facility that you have. In this particular one, I'm using Extra Backup, and so I have this integrated with Extra Backup. When I say backup, it goes out, calls Extra Backup, which is a Percona project, and does a backup. You can integrate it with MySQL Dump. Our customer in San Mateo integrates it with the NetApp snapshots. Whatever you happen to have in your underlying disk subsystems or in your environment, you can actually use that for backup. So I'm just going to start up the backup here. The way I do that is I say data source, and I just say the name of the data source, which is These host names also are the data source name. So when I want to connect to a specific one, I use that name. And then I say backup, and I can put it in the background like this. So I can just say jobs like, so basically this is a little bit like the bash script. You can put things in the background, you can foreground them. And now I can still just do other operations, like I can do an ls and see what the state is of this. So let me talk a little bit more about what some of these other things mean. When I do the demo, it will make a lot more sense. Right here where it says progress, so this cluster doesn't have any applications actually connected to it right now. It's not actually processing any transactions. This progress is just remaining at 2. I'm going to start up a load in a minute here. So as transactions are committed, this progress will just increment with every committed transaction. And so if you see the progress on the master as being identical to the progress on the slave, that also means that those two are completely consistent with each other. So they start out consistent, get the same set of transactions, they remain consistent. And the other thing you can see here is this latency number. And on the slave, it means basically the period of time from the time that it was picked out of when it was originally committed until it actually hit the slave and got committed. So the last latency in this one was 0.2 of a second. I can see also the backup has completed here. Okay, so let me show you something about what I call resilience. Let's say that a DBA or somebody has fat fingers and they unintentionally reboot one of the slave database servers or otherwise cause it to crash. I'm going to actually simulate that by just doing the following, like say service M2 MySQL. So I'm going to actually just stop the database server on that host. So I'm actually running on M1, but I can do these distributed operations on all the hosts that are part of the cluster. Okay, so watch the display on the left-hand side. You're going to see the database server, okay, goes into the stop state. And then the cluster actually is now fenced off that host. I call it fenced, but that slave is now in the failed state. What that means is that if an application was connected to that, probably got an exception, and any application that's trying to connect now can never get to that slave. It's actually now fenced off. You have a question?
Yeah, I'm just wondering, what is the latency on the master?
Oh, the latency on the master? It's just a period of time between the time that it got committed on MySQL and it actually got extracted from the bin log and stored in our own internal format. So there's a little amount of time there. Okay, so it's in the failed state. So basically, and what I'll do is I should actually start the load. But what happens at this point is no applications are going to connect to it, so you aren't getting any continuous errors from that failed database server. It's completely fenced off. Applications can't try to connect to it, so they can't get errors. Now, if I can do a simple operation here, which we call recover, and it'll try to recover that slave to normal operations. So I'll just say data source to recover. And so it'll do whatever it needs to do to try to recover it. So in this case, it saw that it had to start up MySQL, so it restarted it. Notice over there, it's actually gone back online now. So it's pretty resilient. If it can repair that slave and make it available again, it goes ahead and does that. As we'll see in the demo in a little bit here during failover, it may not actually be able to recover something to a slave, in which case we could always restore it for a backup. So let me start up the load, which it's pretty easy to do here. Let's see. Okay, so what this is just a Java program that starts up a number of threads. In this case, it's 20 concurrent threads. You can make this a little wider so you can see the output a little better. Okay, so I'm going to try to organize that so at least you can see the bottom of it during the intervening time here while we're going to do the demo. So what this is showing is it's roughly about 1,000 operations per second right now. It's getting this many rows per select. It's doing a fairly low number of writes. You know, basically it looks like about 150, 170 writes per second. This is updated every second. So what I'm going to do now is I'm going to actually show you a switch operation. And so in the switch operation, let me see if I can get this a little better organized. In the switch operation, what I'm going to do is I'm basically going to switch roles between this master on M1 and this slave on M2. And so, you know, the M2 will become the master, M1 will become the slave. And it's going to do that in such a way that it tries to interfere with the application as little as possible. So let me do the switch operation. You'll see some stuff happening down in the application, and then I'll go back and I'll basically tell you how it all worked. So in this case, since there's only a single slave, I'll just put switch. If I had multiple slaves, I could say switch to, and then the name of the slave. Okay, so basically at this point, it said it selected a slave. What it does is it selects the slave that has the lowest latency. And then it flushes transactions from the current master. And so let me explain all that, basically. And let me just stop this display for 1 second here. I'm going to show you something in this output here. So this is the output of the application, but this output right here is actually generated by a tungsten component, which is part of the connector. And so one of the things that's happening is it basically is taking the data source, which is the master, and it's putting it from this online state to the offline state. So that's the first thing it does. So it does that basically while the application is running, and I have this thing configured so that when it's going from the offline state, online state into the offline state, we have to wait up to 5 seconds for the connections to disconnect. And then what it'll do is if any connections remain after that 5 seconds, it will just close them. It turns out that this application just does a connect, disconnect every second, so it generally doesn't have to close anything. The next thing it does is it puts the slave that's online to offline. So just remember, this is all happening inside the proxy. The application doesn't actually notice anything except it's basically hanging at this point because it can't connect anything. The master's offline, the slave's offline. And so that's very critical because once the master is offline, applications can't write to it. Once the slave is offline, applications can't read from it. What we do in this intervening time here is we actually, from the RO manager, we will write a transaction to the master, and we will wait until that transaction gets through to the slave. And what that has the effect of doing is it's flushing all of the transactions that the application wrote up to that point through, and so that we are sure that we have all the transactions that were committed on this master committed through to the slave that's going to become the new master. So it's basically just a very clean flush of all the transactions that were written. So basically what this does is it prevents you from losing any data. Applications can't write. We do the final write. We wait till that write is present on the slave. And only when that write is written through to the slave and the slave is caught up do we actually switch and make it the master. So at that point of switch, the master and the slave are 100% consistent with each other. So there's no possibility of data loss.
A question.
Yes?
If the slave is too far behind, is the switch smart enough to not switch?
Yeah, well, we have a configuration which basically says for either a switch or a failover operation, you can configure how the maximum latency. So typically what we do is we say it's 15 minutes. And so what it basically says is you can't switch to something that's more than 15 minutes behind. But in this case, and it's a good question, in this case what would happen is if the slave is 14 minutes behind, during the switch operation you would actually wait 14 minutes for the slave to catch up before it becomes the new master. Okay, let me foreground this.
But even in Marketo states that the web they have 500 million transactions per day, they are not that far behind.
Yeah, Eros. Yeah, by the way, this is Eros Tarakarpi. He's our COO, and he's also responsible for sales, and he's our main board member. And so he's here with me today. Also, I want to just point out, you guys probably know these guys, Ivan and Jamie, but they're with SkySQL, and we work closely with them as well. And so, we're really glad you guys are here today. But he's mentioning Marketo. Marketo's database server, these ones that have 2 to 5 terabytes of data, we typically see them doing 2,000 to 3,000 writes per second. And they're also doing a lot of reads. And typically those servers are not behind by more than a few seconds during the day unless they get really piled up. So they do switches all the time because they're constantly tweaking their my.cnf configurations. They add memory or do various things with buffer pools. They're constantly they actually have failovers pretty frequently. So failover basically just takes care of they have to fix the servers for that as well. Okay, let's see. So what I'm going to do now is I'm actually going to, instead of just stopping a slave like I did there, I'm going to stop the master. So master is now M2, and M1 is a slave. So what I'm going to do is I'm going to stop the database server on M2. Watch the application down here because unlike kind of a planned switch or planned failover, this is unplanned, and so you're going to see basically exceptions in the application. But you're also going to see that those exceptions will stop pretty quickly because the Tungsten manager has basically said, intervened and tries to stop and fence the failure. So we've got a whole bunch of exceptions basically in the application. But the exceptions have already stopped because the manager detected that failure, and this blue thing here, it basically set that master to a failed state, which means applications can't connect to it. And now it's in the process of failing over, and now actually I can see that the writes have started up again. Notice over here on the left-hand side this was the master, and now it's what's called a shun state, which means besides the fact that you can't connect to it with an application, also you can't recover it without taking some special steps because you have to figure out why it failed and take some steps to basically make it available again. M1 now is the master, so it's basically automatically made this the master and it's running against that master. Okay. So that was a failover. And let me do one final thing here. I'm going to try to recover that failed master to a slave. If I do an ls here, you'll see the same thing that you see in the left-hand display. It's in the shun state. So what I can do, though, is I can say data source M2 recover. What it will try to do is it will try to actually make that failed master into a slave, if it can. And if it can, it'll tell us why it can. So I restarted MySQL because it saw it failed. Okay, so typically this happens if you have any reasonable amount of transactions going. It said basically it's likely that this happened because the slave, the master rather, had transactions that were committed on that master which did not make it to the slave before the failover, which means that now this failed master is inconsistent with the slave. So what we have to do then is just restore it from backup. And that's pretty easy to do. Just take it, cut and paste this command right here. So that's using the database backup that we previously saved when we started the demo. So notice here that this replicator now is in the restoring state, and as soon as this restore is complete and is successful, this will transition from the shun state. Okay, it's restarting MySQL at this point because it's restoring an extra DB backup. That's what's going on right here. And as soon as it's finished over there, you'll see this actually go back into an online state. Okay, it says it was restored successfully, so now we have a slave, so that restore was successful. So our cluster's back in operation. I now have a master again, I now have a slave. Okay, any questions about that particular set of things?
After the restore, did it have to pick up transaction logs from the master?
Yes, good point. So what it did is, an interesting thing about the way Tungsten replication works is, when we did the backup here, inside of the databases that got backed up here is a database that we maintain, Tungsten maintains, and it has metadata about replication. So the restored backup here actually tells this replicator where it needs to start. It's wherever the backup was taken, it needs to start from that point and roll forward. So what it does is it gets restored metadata from this database, figures out where it's going to go, and then it asks this replicator for the next transaction that it had committed at that point, and then just rolls everything forward. So it just does that. Okay, any other questions? Yes?
If I understand correctly, you're not choosing new logs, you actually have some proprietary format.
Yes. What we have is we have something we call a THL, transaction history log. And so what we do is we extract from the MySQL bin log, because that's the record of the committed transactions. When we extract it, we actually convert that into our own proprietary format. And one of the key things that that proprietary format has is it has a, we call it global transaction ID. But basically it's a transaction ID that no matter which process it goes through from master to master, different masters, that's a monotonically increasing sequence. And so it allows us to easily do these failover switches, because unlike the bin log where you have the MySQL bin log number and the offset, it's different from master to master. So you really can't tell which transaction corresponds to this particular bin log offset. So we maintain our own kind of transaction IDs in this THL format. And let me just show you something. So we have a utility THL.
Faster or is it the same as you?
Well, they're on par in most cases with MySQL replication, but one of the things that we've just developed is something we call parallel replication. And in parallel replication, you can get 4 to 5 times the throughput of native MySQL replication. But we can only do this with our own proprietary kind of replication stream. So this is, I'll just show you one quick THL. I'm going to just show you the THL entry for this particular transaction ID. So this is kind of an interesting thing for you guys who are really into the MySQL inlog, and what's inside of it. This is just an interpretation of one of our THL records. The one thing down here is this was the SQL that was, for that particular transaction. If there were multiple statements in this transaction, you would see multiple statements here as well. We also fragment transactions. If transactions are very large, they may be fragmented across multiple THL log records, but they're still executed inside of a single transaction when we replicate them. The other thing that's interesting here, this event ID, this is actually the MySQL bin log number, and that's the offset right there, and that's the thread ID, which was executed. And this is where the transaction originated from, this host. And finally, where is it? Well, and this is the key thing. This is the sequence number. So we assigned this sequence number to this transaction. So anywhere that one of our THL logs is, this sequence number will always have exactly the same transaction no matter where it is. So it's not like a bin log where the bin logs would have different things at different bin log numbers and different offsets. Let's see how we do on time here. Okay. Move along. Okay, so I think that's what I wanted to show you for a demo. Switch back to M1. Okay, that's good. Okay, so the next thing I'd like to show, it's fun, it's show and tell. I really love this stuff. I'm really excited about what we're doing, and it's fun to show it to a group that understands what we're doing. Okay, what we're going to look at now is somebody comes to us with this picture, and what they want to do is they want to get to this picture. How do we actually do that? So I'm going to quickly run through the steps. I could actually do this in just a few minutes because I have many things scripted. But what I'm going to do basically is I'm going to migrate an application that I have. I actually wrote this yesterday. It's a really simple and stupid chat application. If anybody here is a web developer, when you see my web, my forms and stuff, don't be grossed out because they're very crude, but it'll show you what it's all about. So I have a host where it has back here this one. I have a host that I call TT4, and let's see. database there with TT4, and I'm basically going to move the content from that database to this cluster, and I'm going to do it while I have some applications running against it. Now, it's not running a big load or anything. If we were doing this like with a multi-terabyte, it would all take several days and a lot of orchestration and a lot of planning, but in this case, it's very easy. So let me show you what that's about here. Let's see, I have to follow my script or I'll get messed up. Okay, so this little screen here is it's basically updating every second or so, maybe it's every 3 seconds. And it's just monitoring the state and content of a couple tables that I created. The top table is I basically have a portal user, and right now I have 4 users. These are the guys from SkySQL and Arrow and I. And the bottom one is just what I call a chat table. So basically I can add rows to that chat table by just typing a few commands. And so this data is actually on the TT4 server. So this is one server. I'm going to migrate this data from this server to another place. So what's going to happen here is as I modify the database, you'll see it updated there. Okay, so I can do like invite. As I said, this is really crude. Okay, so basically, as I add, I just basically started a chat. I can do a get on that chat, and as I do the get, the was received changed from 1 to 2, or from 0 to 1. And if I can add another message, I can do put 1 to. So all I'm doing is I'm just, I'm chatting with somebody. It's not a very good chat because it's really, single duplex. It's one direction at a time, and then I'm going to add another one. I'm going to invite. I just want to show you to get some data in here. Okay, so basically that's what my database looks like. It's on TT4 right now. And what I'm going to do is I'm going to show you, I'm going to try to see what's in the database that's in the Tungsten cluster. Let's see if I get this here. Don't have quite as much real estate as I had. Okay, so right now, this one's basically trying to get that data from a server that doesn't have it. It's just getting an error. It's just very, very crude. So what I'm going to do is I'm actually going to migrate this data from TT4 to M1. And what we'll do is we'll see it show up there. Let me just do that. So here's what the migrate consists of. It's pretty simple. I'm going to migrate this to M1, so it's going to go over to M1. What I'm really going to do when I do this migration is I'm not only going to migrate the data from the current place to the new cluster, but I'm going to set up replication from the old database to the new cluster so that I can keep operations going up here during the migration. So this is typically what we do even with large customers is you get a copy of their data, you stage it in the Tungsten cluster, you set up MySQL data replication between their old legacy system and the new cluster, and then you let it catch up. And, for terabytes of data, the copy itself might take a few days, and the catch-up might take 3 or 4 days. So we're doing kind of a simulation of that. I'm just going to basically set it up so that once I've done this, my dump here, which I'm going to dump on this host, TT4, I'm going to dump it on this host, and I'm going to load it in the host, the Tungsten cluster host, and then I'm going to start up replication from this host, the host that I'm migrating, to the Tungsten cluster. So at that point, what will happen is anything updates I make to the old system will actually be reflected in the new system. So let me just show you that. Yes?
Could you use a different version of MySQL, like migrating from 5.0 to 5.5?
Yeah, there's different techniques, but yes, there's no reason why, as long as the replication will work, and if MySQL replication doesn't, we can set up tungsten replication between a back version of MySQL to another version, so we can definitely do that. We can also set up replication from Oracle to MySQL. We have ways to do that, and SkySQL works with us on these things. We have a replication the other direction too from MySQL to Oracle, so we'll talk about these a bit. So let me just do this migration. Let me just, whoops, hit one. Okay, so it's a very small data set, so let me refresh this. So what we have here now is we actually have the, let me get these two windows together so you can see what's going on. Where's the other one? Oh, I see. Let's put them side by side. So on the left-hand side, TT4, that's where it's coming from. And on the right-hand side is the new tungsten cluster. As you can see, basically the data is over there now. Okay, so now the thing I want to basically prove is that if I update something over there on TT4, I should have the replication now going all the way from the legacy system, TT4, into the tungsten cluster. And that basically proves that I still have a working system, basically. So let me just add one more kind of thing here. Let me see if I can do this so you can see it. So let me do another invite. 24. Okay. Let's do another one. Okay, so as you can see here, basically, those rows are propagating from the old cluster now to the tungsten cluster. So we have replication all set up. So this is showing you basically the interoperability between MySQL native replication and tungsten. It works well together. Okay, so now what I'm going to do is I'm going to finish this migration. And so when I do that, and what's under the covers here is what I'm doing basically. Let me show you. It's kind of an interesting operation. I have my web servers running on two different hosts with HA proxy, if you remember the diagram of HA proxy and two web servers. So I'll show you what I'm going to do here. I have a real simple application that connects to HA proxy. And what it does is it's going to disable the HA proxy access to one of my application servers. And I'm basically going to switch the configuration. So what this does is this just changes the PHP configuration. So I have the PHP app now pointing at the new cluster over here. And then it's going to enable it, and then it's going to disable the other one. So what I'm doing is I'm basically disabling one web server at a time, changing the configuration, and bringing it back up. But what it does is you never have the application without a web server to talk to or a database to talk to. So this is basically a zero downtime upgrade for this particular very simple application. So now what's going to happen when I execute this is this proxy kind of polling thing. You're going to see this change from TT4, which is where it's pointing to now. The application is getting it from that database. You're going to actually see it getting it from the tungsten cluster as soon as I execute this. So let's do that. It happens very fast. But so you can see here now, the application just kept kind of clicking along. You didn't see any errors or anything, and that's because it always had a web server to talk to. But now they're basically both getting data from M1, which is now it's actually totally running on the tungsten cluster. So we can reconfigure the application from a single database on one host to a cluster on another host. Okay, so that's the little demo, the migration. Now let me show you the last part of this, which I think will come in good here.
You mentioned something about using MySQL and Oracle.
Oh yeah.
I'm totally perplexed on that because how do you deal with PL SQL and
Yeah.
sequences versus auto increments and all that.
Well, it's not easy, and typically those are engagements where we have to basically do some translations of things, etc. You know, from MySQL to Oracle, you know, some of the engagements we've done, it did involve a fair amount of, you know, kind of filtering and that kind of thing. So it's not trivial to do. And going back the other way from Oracle to MySQL, what we're doing now is we're working on a few fairly large engagements where we're doing the change capture that Oracle provides, using that to create our THL, which you've seen. And once we have THL, we can do anything we want with it, which means we could even apply it to Oracle, or we could apply it to MySQL, or replicate it to Postgres, or put it into JMSQ. There's lots of things that you can do with it at that point.
You guys actually can do a live demo of that MySQL replication. Go online, suppose, and order a pair of shoes. And if you actually get the shoes, thanks to the personality. They have a front-end system that's running on MySQL, the basic order entry system, whatever you see with that. And then they have a backend or a fulfilling system on the Oracle database. So basically, we capture that all the transactions come in MySQL, feed in the backend Oracle system. It's a pretty high volume environment, but maximum like 5,000 transactions per second.
Okay, the final thing that I have time for tonight, there's a lot of stuff here, but this is basically what we're going to have time for, is what we call the multi-site features. And I'm going to talk about something that we call composite data services, explain what it is in a minute. Instead of switching a master on one site, you can actually switch the master. One site becomes a master, another site becomes a slave. You could switch operations from one site to another as simply as what we did here. We could just say switch. And then I'm going to show you a couple other things about basically how you can read on a remote site. Yes?
Why can't we use the existing server as a part of the cluster, some cluster? Because
Well,
I already have that server. Why
Yeah, you
can't I
could.
use that?
Yeah, you could. As a matter of fact, the other way you could do this is you could actually just make that your master and then add new slaves. You could easily, and typically that's, people also do that, is they don't have a huge data set, because this was a case where the application has to keep running, so you can't put the system down. We could still even do that with Tungsten without the migration that you saw. All you have to do is basically install Tungsten on that host where the master is, set up the slaves. You don't have to provision the slaves, but you could do that as well. Yeah, and we do that, yeah. Okay, what's a composite data service? This is a term I cooked up to solve a specific problem. So let's say you have a need for a cluster in San Jose, but you have to have a DR site, or you have to have something else happening in New York, just some sort of a backup. So what I was trying to do is I was trying to figure out, well, how can we actually structure this in such a way that people can do the kinds of things that they want to do easily, which is I want to switch now my operations from San Jose to New York because I have a power outage going on here or something, or I have a site failure, I want to switch operations to New York. What would be the best way from a kind of conceptual standpoint to do that? So what I came to was, well, why can't we just treat this entire cluster as if it's a database server? Just make the entire, and that's what it is anyway. It looks to the application like it's a highly available database server. So this is what we call a composite data source. Is this entire data service itself becomes, in the application, it becomes a data source. So to the application, it just looks like a master. That's all we really care about. Now the interesting thing about this master is you can, inside of this box here, if the application is talking to this, it's the same thing we just saw. There's a failover. This slave becomes the master. This becomes a slave of that master. By the same token, then, we can also make this thing over here, if we have replication running from this site to the other site, we can make that one a slave. So what you have is you basically, you have a physical data service here, physical data service here. You have this physical data service becomes a composite data source. This becomes a composite data source, and this entire thing then can be considered to be a composite data service which has a name. And this is one of the things I didn't really explain. And this is all pretty high level tonight. But when applications connect to Tungsten, they don't connect to a database server. They connect to a service. And in fact, they actually are connected to a service name. This service name right here is SJ. This service name is NYC. And the service then just provides these properties of high availability and scalability and some of those things. So that's you know, kind of in a nutshell. So once you have these services, you can do things like multi-site failover. And you know, just like I did, and I'm going to show you this in a demo, you can basically say switch to New York, and the application will do the same thing it was doing before when I did the switch. All that coordination will happen, but it's happening basically across sites rather than just within a data center. So this is what it looks like. Or this one fails, for example. So if that one fails, then what we do is you actually, now in this case, we don't have automatic failover, because when you have multiple sites geographically separate like this, it could be a little risky to do an automatic failover. So you want a human to decide, do I really want to do this? But once it does it, then you know it's kind of the same outcome, which is you end up with New York and all of your applications basically using the database servers in New York instead of in San Jose. So let me show you this in a minute. So I actually have another cluster. I have a New York City data service set up already, and I'm going to show you how we actually combine them together into one data service. Create a composite data service, I'll configure the apps to use that composite data service. We'll start a load running against it, and then I'll just switch. Okay, so I said I'd get back to this, and I am now. So notice I have SJ here as a data service, but I also have one called NYC. So let me just do this one here, get to this viewer. So in the same way I have a viewer for this cluster right here, this data service, I have another viewer here for New York. So what you can see here is it's a little different. The New York City service is a little different. This is a master, this is a slave, and this whole thing will become our master because it has the master. But in New York, notice that top one there, it says relay. Basically what's happening is this thing is basically a relay for data that's from this data service. So anything that actually gets updated here, you can only write to the master. Any writes here basically get propagated over through this relay, replicated locally, and then also propagated to this slave. So the replication goes all the way through the circuit here.
Is the latency on the New York slave including the latency for the relay, or is it just from the relay?
Basically, it's all end to end. It's all the way from this one all the way out. Yeah. So it's basically however long it took it to get from here to here, and then from here to here. That's not too bad. Okay, so what we're going to do now is, in this place right here, is I'm going to create one of these entities called a Composite Data Service. I'm just going to give it a name, SJ_NYC, and then I'll use that one. And if I do an LS, it doesn't have any data sources. Data sources for a composite data service are actually other database services. So I say create composite data source. SJ. Okay, since SJ basically has the master, it makes it a master for this composite data service, and I'll do the same thing for NYC. So now if I do an LS, so notice in this listing, there's a lot less detail here. In some sense, these are almost like aliases, or they're kind of like placeholders. That one will go online in a minute once the rules kick in. Okay, so now basically, if my application connects to this service, if it tries to do a write, it'll get to the master, and I can configure it so that it can actually read from the slave. And so what I'm going to do now is I'm going to start up an application which actually is using this composite data service. And let's see how I can do that. Not real speed here. So I pre-configured an application so it uses that service. Okay, so let's take a look at our little monitors here. Let's see where that application is actually connecting to. So notice this. So right now I have 10 connections on this master, and I actually have 9 connections on the slave. So New York City is acting as a slave in this case. San Jose is acting as a master. And I have this thing configured so that it basically has affinity to read from New York City, which means if it's trying to do a read, because by the way, you can have these applications running in New York City. If an application runs in New York City against this Composite data service, if it needs to do a write, the write will actually be routed to San Jose because that's where the master is. But if it does a read, it can choose to read from a local slave. So this is a very typical kind of thing. And my application is just kind of clicking along there. It's the same application that we saw earlier, but it's now basically running on top of this Composite data service. So let me now, let's see if I can do this. Let me do a switch while this is running. It takes a little longer for this switch to complete. It's doing more stuff. Let's see if I can keep that visible. Okay, so I'm just going to do switch. It's going to switch basically. The San Jose will become the slave and New York City will become the master. So watch the colors in the displays there because it's basically going to take various things offline. So again, it's going to flush through this master so it makes it unavailable from the application. It's going to use that relay as the new master eventually. So it's going through all the process of reconfiguring everything across these 2 sites. The application in the meantime, it's not getting exceptions or anything. It's just basically not being able to connect to the database, which is why it says 0 right here. But it looks like it's finishing now. You know, I can see that the master is now available. Okay. So now what you see is that it's switched the roles now. So San Jose now has the relay. It's the slave. New York City now has the master. The application is just running as it has been while all that happened. So it basically did this cross-site switch, and I could also just switch it back. And so notice in this case, the master now has 10 connections here, and the slave is basically getting the reads over here. Because this application is doing reads from slaves and writes to masters. It's set up that way. Okay, and one more quick thing here. I have about 2 more slides, and then I'll take as many questions as we have time for, or as you guys have patience for. Okay, so we have some advanced features in Tungsten, and many of these things that I'm going to talk about now are primarily in the integration of our open source replication and our Tungsten Enterprise product. Kind of integrate these things together. You can also use Tungsten Replicator, the open source one, standalone. And what's really happened is the replicator has moved ahead of, in terms of the kind of new features of the Tungsten Enterprise project, because we got a big, can I actually name who we got the money from to do?
But they made publicly indicating.
It's okay. Okay. So Facebook basically paid us to do parallel replication in the replicator and so the multi-master stuff. So what we did then is, this stuff, they actually gave us a fair amount of money to do that. And so that allowed us to do kind of development on the replicator. But we can put all these things together. So parallel replication very briefly and at a very high level. Like applications, for example, that are sharded on database are natural candidates for parallel replication. Because what you can do is, in most of the cases, you can actually replicate those databases in parallel. And so, again, this customer in San Mateo, every one of their customers has their own database on a database server, so they might have 100 different databases on a database server. And so, since that data is really just a silo, they're completely independent in most cases. So what we can do is we can actually replicate that with a configured number of parallel streams from the master to a slave. And in our testing, we're seeing 4 or 5 times speed up in a lot of those cases over, and this is over MySQL native replication, which is actually pretty fast and pretty good. So it's a big, big speed up. The other thing is, the picture that I had before had this one one as a master and would have that one as a slave. But we're actually moving to where basically they both could be masters, multi-master operations, which means that the SQL, the replication goes in both directions. And I was talking to you a little earlier about this customer who's doing a large kind of setup, trying to get to from 1 million users to 1 billion users. Well, one of the ways that they're going to do that is go from a single site like this to basically a star topology. And we actually have this running in Amazon. We're actually building this in EC2 right now for this particular customer. And they have a setup very much like this. So each one of these is a Tungsten Enterprise cluster. They're interconnected with our Tungsten, the advanced replicator, doing multi-master replication. And the key thing here is that this application that they're running is such that they have some data that has to be globally replicated that's referenced by all of the users of this application. Yeah, but they also have some data which is only replicated locally. So this topology, what it provides is it provides the replication of this global data, but it also provides high availability and scalability inside the Tungsten clusters for this local kind of user data that they have. And in fact, this picture that you're seeing here, this is basically a sharded application. So this is just one shard, and they're going to have probably tens or 20 or 50 of these shards out there. So each one of these, so there's data sharded here, and there's data sharded globally. So it's a very, very large kind of undertaking. And they selected us to use basically for the clustering of commercial product, and then we're providing services to them to do the integration with the open source to do the parallel replication. This is actually all running. I'm real happy to see it. Matter of fact, the last couple of weeks, that's all I've been working on is getting this thing set up and running. So it's off and running. But as I said earlier, before they came to us, they didn't have a sharded application. And so what we're working right now is we're working on them with the design of the sharded application so they actually can do the application level sharding. By the way, we're also going to extend this multi-master replication. Once the sharding is in place, we'll have parallel replication across a lot of these channels as well. So it's actually going to be a many months worth of project for us. So that concludes the presentation. And I'd love to hear questions and answer your questions, any questions we have, or comments. Yes, that's correct. Okay, thanks very much, everyone.
Just one question.
Oh, yes.
Do some kind of load balancing on the slave, like to send all queries to the slave, or just the slave is waiting to switch with the master?
Load balancing for read operations?
Yeah,
we have, there's some of the things I didn't talk about, but this connector, it actually has the capacity to load balance reads across multiple slaves. So yeah, let's do a round robin. But what it does actually is it's kind of a weighted round robin where it'll select the slave that is the least, has the least latency. Of course, as that one gets more loaded, it'll kind of move down the line and keep using other slaves. So.
Is it possible to configure like if one slave has 60 seconds of latency, don't send any queries or something like that?
Yeah, well, it kind of works that way because, well, we don't do that, but it kind of works that way. As soon as one starts to get more latency, we'll stop using that one and kind of move it along. Yeah, because we actually track the latency of every single slave at that application level, so we can always route things based on that. As a matter of fact, I had something I wanted to show you where you can configure your application very easily without, just changing. Basically, you just add something to the database name, and that thing you add to the database name says, for example, only send reads, send any reads from this connection to a slave, but only if the slave is within, 1 second of being up to date, or completely up to date, or 1 minute. So you can do that as well. It's very easy to do.
Any other questions?
Okay. That does it. Thanks
Edward
very much.
Archibald, CTO of Continuent.